This video will be your tutorial for Chapter 20 in Pallant, the mixed between within subjects analysis of variance. This is a repeated measures analysis, and I'm sure glad I have a book like this one because I find organizing and then interpreting this type of test to be really annoying and difficult, mostly because I don't do them very often, so I often forget the steps that are involved. And, the output, the SPSS output for this kind of design can be really confusing. I'm including it as part of PSY 222 because over my years of teaching the SCE, my students have frequently designed studies that are a mixed between within design, a repeated measures design with one within subjects independent variable and one between subjects independent variable. So I felt like it was worth it to have you get a little bit of experience running one of these designs. Now the data set that you're using for this particular homework is the experim.saves file. We've used it one other time, so you should still have access to it. What we're going to be doing is looking at the changing confidence ratings at time 1, time 2, and time 3, comparing two different classes. One is a math skills class and the other is a confidence building class. Now, not knowing a great deal about this study, I'm assuming that you would predict that confidence ratings would improve more for the students taking a confidence building class as opposed to a math skills class. So what we're going to test is whether or not there's an interaction between time, so the passage of time is our within subjects variable. We're looking at changes in confidence over time, and whether there's an effect for the type of class. The interaction is over time, is the effect of time on confidence, does that depend on which class the student is taking? So we're going to follow the directions that are on page 292 and 293 in your Pallant textbook in order to run this analysis. So we start by clicking on our usual and analyze, and then we choose the general linear model and we go down to repeated measures. Now under within subjects factor name, you get to pick a name for your variable. So we pick time, and then you have to tell SPSS the number of levels. And since on your homework sheet it says we're going to choose confidence at 3 points in time, so time 1, time 2, and time 3, that means there are 3 levels. And then we tell it to add. And then we click on define. So up here, you see these little question marks and 1, 2, and 3. We've told SPSS there are 3 levels. Now we need to get the right ones. So we choose confidence at time 1, confidence at time 2, and confidence at time 3. So those represent our within subjects measures of confidence. So all subjects, regardless of the class they're taking, complete a confidence measure 3 times. So it's within subjects. Then we need our between subjects variable. And in this case, it's type of class. So we put that in the between subjects box. Then we go over to options, and Pallant suggests that we choose descriptive statistics because we need the mean, standard deviation, and N. We also want the estimates of effect sizes, and we want the homogeneity tests so that we can determine whether we violated any assumptions. And then we click continue. In the plots box, on the within groups, click on the within groups factor, so that would be time, and we want to put that in the horizontal box. And then we want to choose the between groups variable, so that would be group, and we put that in the separate lines box. And that's going to create a line graph for us. Then we click add, and it should say time by group. So basically you're going to be able to visualize the two lines for the two different groups across time. And then we click continue, and we should be good to go. So we click OK, and that's what we've got. Now the output, and you know, like Pallant says, there's a lot of irritating output when you do one of these analyses, and she gives you, you know, a really useful way to interpret all of this. The interpretation information starts on page 296 in your textbook. What I want to point out is the within subject factor, just to remind you, you're testing within subjects. This is the repeated measures variable, confidence assessed at time 1, time 2, and time 3. The between subjects factor is which class they're in. And here you can see how many subjects are in each group. So you've got 15 participants in the math skills class and 15 participants in the confidence class. The descriptive statistics, that's what you look at first. So this table gives you the mean, standard deviation, and N for your math class and your confidence building class at each point in time, plus it gives you the total. So the overall, regardless of which class they're in, you get the mean, the standard deviation, and the N. The next thing you want to look at is whether or not you violated the equality of error variances assumption. So you need to scroll down and look for the Levine's test of equality of variances. What we want to see is a non-significant result, because that will mean that we can assume that we have equality of error variances. And what you see is that you have all of these values are non-significant. The next thing you want to check is the boxes test of equality of covariance. And we want a significance value that is bigger than 0.001, and our significance value is 0.275. So we're good there as well. The next thing you want to do is you want to look at the interaction effect. And this is where, you know, when I look at all this output with my students in SEE, it's like, well, that's an interaction, time by group. And I look down here, though, that could be an interaction, that's time by group. I don't know which one to look at. So what we look at is we go under multivariate tests, and we look here where it says time by group, and you'll notice that all these values are the same. These are 4 different statistics for testing for the interaction, as well as for the effective time, the within subjects variable. The one that is typically reported in journals in psychology is the Wilks lambda. So we want to look at the significance value and the partial eta squared. The significance value here says to us that the time by group interaction is in fact significant, with a small effect size. So what this means is you've got an interaction effect that is statistically significant. That implies that interpreting your main effects for both the within subjects variable and the between subjects variable is not straightforward. So the main effects, I asked you in the homework, is there a significant main effect for the within subject's independent variable of time? And number 3, I ask you, is there a significant main effect for the between subjects independent variable of group? Since you have a significant interaction effect, what you should do is interpret the interaction between the two variables instead of interpreting the main effects in a straightforward way. If the interaction had been non-significant, then what you would report and what you would interpret is just the main effects. But since we have a significant interaction, that should be the focus of your reporting. So when you answer the questions 2 and 3 in this homework, what you're highlighting is the fact that you have a significant interaction, and therefore it's not appropriate for you to focus your attention on the main effects. Instead, you're going to look to the plot in order to help you understand it. But just for your education, let's look at the main effects. And again, it's really challenging with all of this output to decide what am I supposed to be looking at here. If we stick to looking at the Wilks lambda up here for the effect for time, you would, if you didn't have this significant interaction, you would look at this and say, yeah, I have a majorly significant effect for time with a moderate effect size. And then you could describe that. But again, since we have a significant interaction, we are not going to interpret that main effect. For the between subjects variable, if you look at the tests of between subject effects, down here, you're looking at the effective group, and what you would see, let's say, if we didn't have the significant interaction and we were going to interpret this main effect, it would be non-significant. Now, again, I'm showing you these parts of the output just so that you know where to look for them. Notice that you've got all of these other significance test results, but we're not using them. Now, I have seen some researchers who report the greenhouse geyser results. I'm going to go with Pallant here and just use the directions that she is providing you at this point in time. If you go to grad school and you take a multivariate stats class, you'll learn the nuances of these different significance test results and when to use them and when not to use them. But that's kind of above your pay grade at this point in time. So the next step is to look at the plot as far as being able to describe the impact of time and its interaction with type of class. So basically, when I look at this plot, I notice that the two classes, they're equivalent at time 1. By the time we get to time 2, though, we have a pretty substantial gap, and by time 3, that gap persists. So how would you describe this result? Since these lines are they're not completely not parallel, but they're really not parallel either. So what you can say is that while there appears to be an overall effect of increasing confidence with time, the effect is much stronger for those students in the confidence building class. Let's say that the researchers had a hypothesis that confidence building class would have a more dramatic effect on confidence ratings over time, so you'd see a faster building of confidence with an actual class designed to build confidence than you would in a class designed to teach math skills. So they're learning math skills and they get some confidence boost, but not nearly as much as if they were taking a confidence building class. Now, in your homework, when you go in and you are reporting this for in the quiz space on D2L, follow the guide for how to talk about these effects from Pallant Pallant gives you an example where you are actually interpreting your main effects. In this case, you're going to, for part A of your homework, you can say that the interaction between type of intervention and time is significant. Your p-value is 0.043, and let me remind myself of the partial eta squared of 0.207 with a small effect size. When we inspect the plot, then you can say an inspection of the plot suggests that confidence building showed a greater improvement in confidence levels following the intervention than the math skills group. Now for parts B and C, I ask you, is there a significant main effect? Well, since there is a significant interaction effect, it's not really appropriate to interpret the main effect. While you can see both in the significance test results for time and also in the plot, you can see an effect for time for both groups. Since there is a significant interaction effect, you really focus your attention on that. Same for part C. The interaction is significant, so it's not appropriate to interpret the main effect for group. So you can eyeball the plot and you might be able to make an argument that there are differences, and you can look at the main effect significance test and you can say it's non-significant, but really what you have is an interaction between the two variables, so you should focus your attention on that interpretation. And that concludes my tutorial for chapter 20, and that is our last tutorial for the semester.